Welcome to Chapter 4. You'll recall, maybe you'll recall, that the name of the course and the name of the book is Structure and Interpretation of Computer Programs. And we've done the structure part, and now we're starting on the interpretation part. So what does a computer program look like, and what does it mean? And now we're looking at how is a computer program understood by the computer. The big topic this week is the metacircular evaluator. That's a big name, which I'm not sure I understand even yet. I understand the circular part because, well, no. There's two kinds of circularity involved. Maybe that's why it's called metacircular. One kind of circularity is a mutual recursion, which you've seen before in the calculator program and the Scheme 1 interpreter, which is the mutual recursion between eval and apply. So that's one kind of circularity. And the other kind of circularity is that it's a scheme interpreter written in Scheme. We could use a different programming language, write an interpreter for Python or something. But there's two reasons why Scheme in Scheme is a good choice. One of them is Scheme is the only language that we're sure you all know. And the second one is, as you'll see, Scheme is a really, really easy language to write an interpreter for. It's probably the easiest one there is. So there's this picture on the board here, which I may have shown you, I don't remember, when we were talking about Scheme 1. But on the left, we have a function machine. So it has an input hopper and an output chute, and it's the function x maps to 3x plus 7, and I put a 5 in at the top, and I turn the crank, and out comes 22, just like you learned about in middle school, probably. And what's on the right is something really different from that. It's a machine that has two inputs. The right input is data, just like in the first machine, but the left input is program. So it takes a machine as input. And this machine is a universal calculator. It can calculate, this one on the left calculates a particular function. The one on the right calculates any function because you find a way to encode the function you want in a form that we can present to a computer. In our case, that's a Scheme program. So we would write lambda of x plus times 3x 7. And that's an encoding of this machine, which we can use as an input to this machine that, following the textbook, I've represented using a yin-yang symbol. Yin and yang are a mutual recursion. That's why there's a little dot of yin in the yang half and a little dot of yang in the yin half. And that is supposed to remind you of the mutual recursion between eval and apply. And this machine is a universal machine. And let me remind you that this idea of universality is the thing that made the modern computer revolution possible. That long, long ago, we had machines that could compute particular functions. Okay, so back in the days of Archimedes, they had very complicated machines full of gears and things, and you would turn a crank and see all the planets rotating. But it's not until the 20th century that we had a universal calculator, despite certain sort of false starts, like Babbage's famous machine that was a kind of universal calculator, but he never got it built, basically because he didn't have electronics, and it's too hard to do mechanically. But today we have universal machines, and that's what makes it possible for people to build new computer applications really easily. You know, you can sit in your back room and program up a new invention. So it's a really, really important idea. And that's why it's important why you understand this notion of interpreting a program.